Hi everyone, my name is Pham, and this is my proposal study about the migration of phthalates from single plastic containers to food under high temperatures. In the food industry, packaging plays an important role. Packaging provides protection and cheap, efficient ways to handle food. Recently, due to the novel coronavirus, today's dine-in was limited in many places, and to-go food is much more preferred. However, many restaurants or food stalls are packing hot food like soup um, or ramen in plastic containers, or food wraps of hamburgers and sandwiches. And this raised the questions of whether chemicals can migrate from to-go food containers to food under high temperature. So, in 2018, researchers from the George Washington University found that people who were high consumers of food purchased outside of the home had 55% higher levels of phthalates compared to those who only consumed food at home. In the data graph on the right, you can see that on three groups, the percentage of phthalate level is high, especially in adolescents above 12 years old and adults in their 20s. So what are phthalates? Phthalates are often called plasticizers, which are defined as chemical substance that when added into a material can alter the physical properties of the materials to increase the flexibility, elasticity, and color. Phthalates are identified as diester of orthophthalic acid. In the structure in the right, we can see that phthalates are an aromatic dicarboxylic acid in which the two carboxylic acid groups are located on adjacent carbon in position 1 and 2. There are many types of phthalates. There are DHP, DBP, DIMP, DIPP, and many more. In this research, I will focus on DHP and DBP. So the reason why these chemicals DBP and DHP are concerned because they're carcinogenic. In females, DBP increases transcription of an estrogen-regulated gene in breast cancer cells, and DHP shortens the duration of pregnancy. Phthalates can also harmfully affect the male reproductive system. The objective of this proposal study is to detect and quantify the target phthalates, which are DBP and DHP in food simulants, and then I will compare with the European Food Safety Authority assessment of toxicity threshold. Many of you may have a question here, why do we use European regulation standards instead of US? Well, first of all, because European standards are easier to look up than US standards. However, this doesn't mean that we don't have our own standard. It's just that the standard vary by state such as California, Washington, Oregon. The second reason is that they seem to have more experience done, especially in the migration from packaging to food. The overview of my research plan is I will be using food simulants, ethanol 10%, acetic acid 3%, and vegetable oil. Ethanol 10% is used to simulate hydrophilic food. Acetic acid 3% is used to simulate hydrophilic foods with pH less than 4.5, and vegetable oil is used to simulate lipophilic food. The samples will be treated at different high temperatures, ranging from 70 degrees to 100 degrees Celsius. The concentration of DBP and DHP will be analyzed using hydrochrome liquid chromatography. To assess the migration of phthalates into the simulants, the concentration of target phthalates are divided by the total surface area of the containers that are in contact with the food simulants. The results can be then used to compare with the specific migration limit. So the projected time for this experiment will be 5 weeks, 3 days. The first week will be used to do experiment testing on one testing sample so that I can verify the possibility of the method. Um, I expect to spend 2 days on sample preparation for one similar solution, 1 day for phthalates measurement, and 1 week for sample analysis. And then it will take 3 weeks to repeat the experiment for other food similants. The material for this study will include 2 plastic soup containers, which will be collected from local restaurants, analytical standard DBP 99% and DHP 99.5%, and the internal standard of 99% I use to quantify the migrated parties into food stimulant, ethanol, and acetic acid, and vegetable oil. The instrument high performance liquid community. For the instrument, I will use purified water and acetonitrile as mobile phase, and Luna is C18 column as stationary phase. The mobile phase program is based on the study of Garcia et al. 2013. So, how I would extract phthalates is that first, two signals are preheated at different temperatures, 80 degrees, 90 degrees, and 100 degrees Celsius. Then I will fill up to 2/3 of the plastic containers with two signals. The sample is collected after 30 minutes and then concentrated using a nitrogen blow-up unit to 1.5 ml max volume and stored in the freezer for HPLC analysis. Lastly, showing here is an example chromatogram of an HPLC analysis. The method of quantitation is that I will find integrated peak area for DBP and DHP. Then using the known area and the known concentration of the standard, I will be able to I will be able to calculate the response factor using the internal standards. Then I will be able to use the response factor to solve for the concentration of phthalates in my samples. And this is the end of my presentation. Thank you, everyone.